All right, well, thanks for having me. I live just up the road, actually, so it's really convenient. Um, so let's see. I'm just going to tell you the story of how I got here and just did the things that I did, and then any questions that you have, business, technical, or otherwise. So I'm happy to answer. So let's see. I grew up in South Africa. Left there when I was 17. Went to Canada for a few years. And then came down to the U.S. to go to college at the University of Pennsylvania. Did a dual undergrad in physics and business. And actually, what originally drew me out to California was I was going to do a PhD at Stanford in applied physics and material science, working on energy storage mechanisms for electric vehicles. In particular, high energy density capacitors. Just as I was about to start that program, the internet looked like it was going to be something significant. And when I was in college doing undergrad, actually, I'm going to go to the handheld mic because I'm getting a bit of variation. Sorry. So, great. So when I was doing my undergrad in physics, I tried to think of what are the things that would most affect the future of humanity. The three things that I could come up with were the internet, sustainable energy, both the production and consumption of energy, and third was space exploration, but particularly the extension of life beyond Earth, making life multiplanetary. I didn't actually expect to be involved in the latter. So this was simply considering, in the abstract, what would most likely, what would have the biggest impact on the future of humanity, as best I could determine. Initially, I thought, well, I'll try to do something in electric vehicles as part of the sort of sustainable transportation part of the problem, and that's what led me to come to California to sort of try to figure out, can you make a high enough energy density capacitor to replace batteries. And then that summer of '95, it became clear that the internet was going to be something very significant. So I thought, well, I can either spend sort of 5 or 6 years doing research on ultracapacitors and ultimately find out that success is not one of the possible outcomes. Or I could take part in building the internet, and that seemed like a better likelihood of success. And I knew I could always come back to Stanford, so it didn't seem like all that risky a thing to try. So I called up my professor and said, can I go on deferment? I'll probably be back, and he said, well, this is probably the last conversation we'll have, and it was. So I just started writing software in the summer of '95, and that software ended up becoming the basis for Zip2, my first company, which helped bring the newspapers online. So we had the New York Times, Knight Ridder, Hearst, and so forth as investors and customers. This is the very early days of the mass market internet. And that worked out reasonably well, and ended up getting sold for about $300 million. But that gave me the capital to sort of do something more on the internet. And I thought that there was an opportunity to really apply innovation to financial services. And I wasn't sure exactly how, but it seemed like money is just an entry in a database. It's low bandwidth. And so there should be something useful that could be done. And we initially started out trying to create this financial services hub that combined banking, mortgages, credit cards, and all sorts of things in one easy-to-use place. And then we had this little feature which enabled you to email money from one person to another. And then whenever we demonstrate things, that people would love the little feature and nothing else, even though the feature wasn't that hard. So, like, well, we should probably, amplify this feature. and that turned out to be quite successful. About a year after we opened the website, we had about 1 million customers, and we didn't really expect 1 million customers. Sort of like expecting the Spanish Inquisition. I mean, it's just not something you expect, you know. We had all sorts of growth problems, and God help you if you needed to reach customer service, you know. But things worked out pretty well on that front. And then about 3 years later, we sold that to eBay for $1.5 billion. And the great thing about that was it gave me the capital to start companies that were quite capital intensive. And that's where I thought, okay, you know, I've got some money. Let's see if I can do something in the space arena, and in the electric vehicle arena and solar power. The one I sort of worked on first was space. And I picked that first because there's not really a fundamental economic forcing function for space exploration. Whereas there are economic forcing functions for sustainable energy. They're weak. They're weaker than they should be because of we're not incorporating the negative externalities. But they're still there, and but they're not really there for space. So I thought I'll just do space because that's something that somebody has to decide to do. And the goal with SpaceX is to try to massively improve the cost and reliability of space transportation. In particular, we want to try to invent the first fully reusable rocket system. So the only semi-reusable rocket system that's ever flown really is the space shuttle. Actually, the Russians briefly flew one, but then retired it because they thought it didn't make any sense. But the space shuttle is semi-reusable. The main tank is thrown away every time, and the parts that are reusable are so difficult to reuse that the space shuttle costs about 4 times more than an expendable vehicle of equivalent payload capability. It's about $1 billion a flight for the space shuttle, and it can only go to low Earth orbit. So if we aspire to become a multi-planet species and ultimately make true the things that you see in science fiction movies and read in science fiction books and exciting things about the future, the space shuttle ain't the way to do it. So we have to create a reusable orbital transportation system. People may ask, well, what's so great about reusability? Is that really necessary? And I'd point to really any other mode of transport. And if you look at that and said, if it was not reusable, whether it was a bicycle, a horse, a plane, a boat, how much use would it see? And it's almost nothing. If you look at air flight, a 747 costs about $250 million. You'd need 2 of them for a round trip. And probably most people wouldn't be paying $500 million to fly from LA to London. But the reason that you can pay $2,000 for that same trip is because a 747 can be reused tens of thousands of times. And so the capital cost of the 747 is quite small. We have to get to that same situation in space. But it is a much harder technical problem because Earth's gravity is quite high. It would be much easier if Earth's gravity was just a little bit lower, but it's difficult to negotiate with gravity. If you design a rocket well, you'll get about 3% of the liftoff mass to orbit, to low Earth orbit, for an expendable system. That doesn't leave a lot of room to add reusability, because you need heat shields, you need to do a deorbit burn, you need recovery systems, It's got to be robust against multiple flights. So pretty soon you chip away at that 3% and you end up with nothing. And so there's been many attempts to create a reusable system in the past, and they've all been cancelled when they concluded they would ultimately not get anything to orbit. So this is a very, very difficult problem. I think it's one of the most difficult technical problems possible. But we're going to give it a shot. So far we've managed to produce, I think, some pretty decent expendable launch vehicles. And recently we were able to recover our spacecraft, our Dragon spacecraft, which is effectively like the third stage of the rocket. So I'll show you a few videos. So this is Falcon 1. This was our first rocket. It's a little hard to see. So Falcon 1 takes off from a remote tropical island in the Kwajalein Atoll. It's about halfway between Australia and Hawaii. It certainly made for interesting cocktail conversation when people ask me what I did. So launch rockets from remote tropical islands. They sort of expected me to show up with a white cat. By the way, the song that we're sampling here is High Roller by the Crystal Method, so that was appropriate. So that was definitely a happy day, I tell you. There's a I should probably mention that was flight 4, so the first 3 weren't quite as good. So I'll show you then Falcon 9 and the first flight of the Dragon spacecraft. It isn't completely obvious because those towers are really gigantic. That Falcon 9 is a very big rocket. Falcon 9 is about 18 stories tall, has 4 times the maximum thrust of a 747. It's about 1 million pounds of thrust, and or relative to other rockets, it's a little bigger than a Russian Soyuz. And this was really, Falcon 9 was really designed to carry people to orbit. So it's designed to meet all of the NASA's human rating specifications.
First 2 M9 engines shut down. First stage MECO 2. First stage engine shut down.
Second stage has separated. Initial velocity of MECO was approximately
MVAC ignition confirmed.
8.2 kilometers per second. Now on. Dragon nose cones been jettisoned.
So Falcon 9 is capable of putting about 12 tons into orbit, whereas Falcon 1 is capable of putting about just over half a ton into orbit.
Second stage propulsion is performing
And
nominally.
NASA a couple of years ago selected Falcon 9 and our Dragon spacecraft to replace the cargo transport function of the space shuttle, so the space shuttle retires this year. We'll be taking over from the space shuttle.
Orbital parameters approximately 288 kilometer perigee, 301 kilometer apogee. Inclination 34.53 degrees.
Obviously, speed it up a little. It takes about 90 minutes for Dragon to circle the planet. And we touched down just off the coast of California. So initially we were landing in the water just to make sure that we can land where we intend to land. You know, if we started off landing on land, we would perhaps inadvertently land in, on UCLA. That would be unfortunate. Depending upon your point of view. So we started landing in the ocean because that would allow for a large aero dispersion. As it turns out, we were accurate to within about a mile, so this was a good flight, for sure. But then in a couple of years, we'll be transitioning to landing on land. And then hopefully a little bit after that, we'll be landing propulsively with landing gear on land, kind of like the Eagle landed on the moon. I'll show you that, a little bit of that video. is just this is something we just recently proposed to NASA for upgrading Dragon to carry people, which means adding, mostly it means adding a launch escape system. And here you see a simulation of a propulsive landing. Yeah, that would be cool. Yeah. I don't know. It's kind of like how real spaceships should land, I think. So, yeah. So far, so good. The next big milestone for us is to deliver cargo to the space station later this year. And it's actually very important that we do that because the space shuttle is retiring this year. And if we don't get the space station by the end of this year, NASA's told us they'll have to demand the space station. So there's a little bit of pressure there. Yeah, I think we got a pretty good shot at doing it. So I think. And then and this stuff is all fine, but as I was saying earlier, the big breakthrough that's necessary, the fundamental invention that's necessary, is a fully reusable rocket system, where both stages of the rocket can be rapidly and effectively reused. So you can do multiple flights a day, ideally, with the same rocket. That will have a massive effect on the cost of space transportation, because the cost of the propellant in Falcon 9 is only about 0.1 to 0.2% of the cost of the vehicle. So you'd have a massive savings. Obviously, just like an airplane. You know, it's if you have to get a new airplane every time, it's a hell of a lot more expensive than refueling it. If SpaceX or some other company can figure out an efficiently reusable rocket system, then that will allow life to become multiplanetary for the first time in the 4 billion year history of Earth. It's a very, very important thing, I think. We'll give it our best shot. I mean, we'll see how we do. But hopefully, if it's not us, then some other organization has to figure it out. Otherwise, this is the only planet we'll be living on, which is fine. I mean, but I think the probability of life as we know it living for a much longer time, and also think if the future being much more exciting, I think it's better if we're a spacefaring civilization out there exploring the stars. I think that's just a much more exciting, inspiring future than if we're just on one planet forever. Now, sometimes when I talk about space, people think that this is sort of an attempt to escape from Earth because of some impending calamity. But actually, I'm quite optimistic about the future of Earth. I think we'll solve the problems that are before us, and Earth is very likely to be a great place for a very long time. I'd say at least 99% likely. Which sounds good unless that 1% shows up. So I think that the right course of action for humanity is to obviously do everything we can to make Earth a great place to live, and have sustainable means of producing energy and consuming energy in particular, but then also apply a little bit of our resources to making life multiplanetary. And I'm not talking about a lot. I'm talking about something, which is obviously far less than we would spend on healthcare, but maybe more than we spend on lipstick. So it's sort of, somewhere in between there is probably good. So then moving on to making Earth a good place to live. That's really what Tesla and Solar City are about. The goal I have with Tesla is to serve as a catalyst for the transition to sustainable transport, which in my belief is really electric transport. And I actually think all modes of transport will become completely electric, with the exception of rocket boosters. Unfortunately, it's difficult to avoid Newton's third law. So you really have to eject mass at a high flow rate in order to get out of Earth's gravity well. I mean, there are some sort of far-fetched methods which, like space elevators and things like that, which I think are unlikely to be feasible. But apart from rockets, I think planes, trains, automobiles, boats, everything, it's all going to go 100% electric. It's just a question of when. And with Tesla, we're trying to make that when happen sooner. Yeah, sure. There you go. Absolutely. So I'm hopeful that when people look back on Tesla, they will conclude that Tesla accelerated the advent of electric vehicles by at least 5, maybe as much as 10 years. In creating the Tesla Roadster, which is an electric sports car, it's a very fast car. It's faster than almost any Ferrari in terms of acceleration, much more efficient than any hybrid car. It's about twice the energy efficiency of a Prius. We were able to. The goal with creating that first car was to kind of break the mold with respect to electric vehicles, where people thought electric vehicles were these sort of slow golf carts with no range and just basically horrible. And it'd be like, and so you'd sort of mention electric cars, and people would imagine this sort of horrible scenario in their minds, where they'd have to give up their nice car and have something that looked like a golf cart that they'd have to plug in every 5 miles. So we really want to break the mold there with the Roadster. I'm not sure if you'll. I'm sort of assuming people are familiar with the Roadster, but I'll not assume that and show you a picture. So it's this is the Tesla Roadster. So not your typical electric car. And this will beat a Porsche GT3 around a test track. It has a combined highway city range of almost 250 miles. And actually, there's one customer recently who managed to drive the car 347 miles on a single charge. The effect of the Roadster was when we unveiled it. Bob Lutz, who was vice chairman of General Motors at the time, saw our press release and the car and everything, and actually took that press release and said, well, if a small company in California can make an electric car, then so can we. And that's what brought the Volt program into being. And then when General Motors said they were going to do electric car, quasi-electric car, then that prompted Nissan to do an electric car. It prompted Daimler, it prompted Toyota and others to also do an electric car program. So it sort of got the whole ball rolling. I mean, there's still a lot to do. It's the very beginning of electric vehicles, and so we're pushing forward with the next step, at least from Tesla, which is to go from a low-volume, high-priced car to a mid-volume, mid-priced car, that's the Model S. Anyway, you can see sort of a bunch of pictures there. This is sort of the Model S sedan. It's a 4-door sedan, and it's sort of about the size of say a BMW 5 Series or an Audi A6. In the case of the Model S, it has a range of up to 300 miles combined highway city. If you drive it very carefully, you may actually get as much as 400 miles of range. It has the ability to recharge in about 45 minutes. and the battery pack, which is in the floor pan, can be switched out in under a minute, so faster than you can fill a gas tank. This is, we just completed the alpha prototype of the Model S, which will be displayed next week at the Detroit Auto Show. The beta is going to be unveiled in August, and then production cars are slated to go to customers in mid next year, so about 18 months from now. And this is really to, the goal of Model S is to show, like, if you really optimize the design of a car around an electric powertrain, just how good it can be. And the Model S, for example, has twice the storage space of a 5 Series BMW. It has about 36 cubic feet of storage space. 5 Series BMW has 17. It has a trunk in the front and a trunk in the back, because there's no engine in the front. The motor is coaxial with the rear axle, and even though it generates over 300 horsepower, it's only about 25 centimeters in diameter. You could, if you're strong, you could actually just pick it up. And we've made big improvements to the battery pack and power electronics and everything. And we've used the battery pack as an integral stiffening structure in the car itself, so the car has greater torsional rigidity than any other anything except a really advanced sports car. This is one of the key metrics of quality in a car. So it's really just going to be quite a spectacular car, I think. And then beyond Model S is kind of our third stage, which is to go to high volume, low price cars. And that's our third generation will probably be out in about 4 or 5 years or so. And sometimes people ask me, well, why don't you just immediately make a low price, high volume car? I'm like, well, I wish we could. But if you're a small company and you do not have the $2 billion and the giant auto plant, you cannot go to the high volumes that you need to go to make something inexpensive. And there's another factor, which is when you have a new technology, it typically takes about 3 major revisions to optimize it. So even if we had the giant auto plant, it would still not be a great car, because you just need to iterate and optimize. That's our 3-step strategy to try to get to mass market electric cars. And then through partners like Toyota and Daimler, we're trying to accelerate that process. So Tesla provides the battery pack and charger for the Mercedes A-Class, the electric smart car, and then in 2012 for the Toyota electric RAV4. So we're doing our best to try to help other car companies bring electric cars to market, as well as bring our own cars to market to serve as kind of a case example of how one might design an electric car optimally. So that's Tesla. It seems to be also doing quite well. The market seems to have a lot of faith in us right now. And then something I haven't talked much about, which is Solar City. Solar City provides solar power systems, because you must have both sustainable production of energy as well as sustainable consumption of energy. Tesla is obviously on the consumption side, but Solar City tackles the production of energy side. So Solar City, where thankfully I do not have a day-to-day role. I'm chairman of Solar City and the major shareholder, but I don't have a day-to-day role, whereas I run SpaceX and Tesla day-to-day. So the guys at Solar City have done a phenomenal job. Solar City is actually the biggest provider of solar power systems in the country by a pretty big margin. If anyone's looking for solar power, I recommend giving them a call. So that's basically it. What questions can I answer? It is not practical to carry an extra battery pack in an electric vehicle. So for the battery pack swap, there had to be some sort of swap station. However, if you have a 300-mile range car, you're really not talking about a lot of swap stations. I mean, you just need, say, one between LA and San Francisco. And then there's a question as to whether people will even want to swap a battery pack rather than simply park their car at a highway or rest stop, grab a meal or a coffee, hit the restroom, come back 20, 30 minutes, and you've recharged enough to complete the journey. I think most people will probably do that. But we wanted to preserve the optionality of a fast pack swap just in case there were people in a hurry. Right, so Better Place actually got the idea of battery pack swapping from Tesla when Shai Agassi came and visited, and we told him that we were going to incorporate battery pack swapping. It was like, oh, good idea. Yeah, well, yeah. Not that I think it's a genius move. I mean, you have cell phones and laptops that have battery packs that swap. But we're not currently working with Better Place. Yeah, and not that because we don't like them or anything. It's just we don't see any sort of technical advantage or anything to working with them. That it is not obvious to us how we make the consumer experience better with Better Place. So yeah. It's sort of on the order of about of 1,000 pounds of propellant that you need to expend to land propulsively. Well, the booster, the rocket booster, is what delivers you to a parking orbit. Then you use a little bit of propellant to maneuver over to the space station. Then depart from the space station, initiate a deorbit burn, control your reentry during the descent phase. In total, there's about 3,000 pounds of propellant. So you use maybe 1,000 in terms of getting to the space station and departing and deorbiting. About 1,000 on landing, and you'd have probably 1,000 spare, roughly speaking. Now, if there was something unusual happened, like you had to temporarily abort on an approach to the space station, then you might use another 500 pounds of propellant or something like that. But we will actually still have parachutes as an emergency on Dragon. So you test the engines at, say, a couple miles of altitude, make sure they're working. If they're not, then you deploy the emergency parachute, kind of like the Cirrus aircraft. Well, it's not yet in production. But on a go-forward basis, well, most of the engineering is done. We're sort of the 90% engineering complete stage right now. The factory, we're fortunate in being able to purchase the NUMMI factory in Northern California, which was jointly owned by Toyota and GM. Although in recent years it's only been making Toyota products. It's where they made the Corolla and the Tacoma. So we were able to buy at a very good price a great factory, and thus minimize the incremental tooling cost to produce the Model S. So there's an existing paint shop, so we only have to modify a paint shop instead of building one from scratch. There's stamping machines and all sorts of things there that are helpful. The two biggest milestones this year, I think, are probably getting our stamping line operational to stamp the aluminum body panels. The Model S is actually going to be the only aluminum car made in North America. The Audi A8 and a few of the advanced German cars are aluminum, but currently there are no aluminum passenger vehicles made in the United States. Although for me, coming from this sort of space arena, it's like obviously you make it from aluminum. What else would you make it from? Like steel is really heavy and not great. And then the second thing is the paint shop. Painting a car is actually really difficult. If you want to get a spectacular paint job, and we're aiming for something called which we call a piano finish, like what kind of things you see on a grand piano. So something that's noticeably better than any other car. And so that's a high bar, and particularly to do so without adding a lot of cost to the process. So I'm optimistic that we'll get, maybe not all the way there, but most of the way there. But those are the two big production milestones this year. So, wow, I got a lot of hands. Somebody way in the back of the room. Yeah. Yeah. Well, I mean, there will certainly be issues that we have to deal with, but the sort of less than 1% chance of, by less than 1%, I mean less than 1% chance of annihilation of humanity. And I mean, even if we do massively increase the CO2 concentration in the atmosphere, it is unlikely to result in the annihilation of humanity. It could kill a few hundred people, a few hundred million people, due to rising sea levels and that kind of thing, which is obviously not good. But it is not an annihilation event. But if you look at the fossil history, there have been several annihilation events, mostly due to meteors, one kind or another, possibly some due to supervolcanoes, and some due to who knows what. But so we obviously suffer from some risk of a similar annihilation event, and also potentially a man-made thing like a super virus, or it could be something like with the CERN Large Hadron Collider. Potentially could see a press release where the good news is we've discovered a new law of physics. The bad news is there's a small black hole that's rapidly growing. No, I think that's extremely unlikely. Clear, but we've discovered new laws of physics before. So. Well, I'm not a venture capitalist. So people sometimes think I'm a venture capitalist, but actually I'm an engineer. So when I apply capital, it is to my own companies and to occasionally to the companies of close friends of mine, where I do zero due diligence, and I just basically invest on the basis that I think they're good and likely to succeed. So I'm not the guy to pitch on ideas to be funded, because I'm not a venture capitalist. It's better to pitch a venture capitalist on that. Well, I suppose if it would help the space program, I mean, that would be quite surprised if that were the case. But it's possible. Yeah, I mean, so surprises are good. It would look a little bit different, not that much different. My view on reusability is you have to take the first stage has to basically turn around, relight its engines, boost back to the launch pad, and land propulsively. It's tricky. It's very doable. And then the second stage is harder because Second stage, your pound for pound trade-off on payload. So any mass that you add in terms of heat shield or reentry systems, it's directly subtracted from the amount that you can put into orbit. Whereas the first stage is anywhere from a 5-to-1 to 10-to-1 ratio. So you can add 10 pounds and it only takes away 1 pound of payload. And there's also a lot more you have to do with the second stage. You have to have a much more significant heat shield. You have to deorbit the stage, control it during re-entry. It's got to have some liftover drag so you can steer it back to the launch site. And then you've got to either propulsively land or perhaps use a parafoil or something like that. All those things cost mass, but that's kind of how I think it can and should be done. That's what so that basic architecture is what we're going to try to do. And the trick is to do it with just very mass efficiently, because you've only got that maybe 3.5% of mass to play with. You want to try to get at least say 2% of your lift-off mass to orbit. So that only leaves like 1.5% for everything else. So not much. Yeah, I think long term you'd see that sort of thing, and maybe even in the initial phase, it kind of depends on whether the country builds, United States builds a super heavy lift or not, like a Saturn V class vehicle. If you have a Saturn V class vehicle, you don't need to do on-orbit assembly. If you have something smaller than that, then you do if you want to go to Mars. So it kind of depends on how things unfold in that direction. I think it'd be great to have a super heavy lift launch vehicle. If it's done in a typical government-driven way, I think will not come to fruition because of massive schedule overruns and massive cost overruns. So it really depends on whether NASA decides to take a commercial approach to super heavy lift. Then there will be super heavy lift and obviate the need for on-orbit construction. And then when there's a lot of traffic between Earth and Mars, I would expect there's probably some large kind of space cruiser that's circulating between Earth and Mars, and then you just basically take a small shuttlecraft up to the space cruiser, if you will, and the space cruiser gets refueled from Earth or from Mars. But that's a long-term optimization, and it would be driven by a lot of traffic occurring between the two planets. Well, I think it's generally good. Well, NASA is our biggest customer for SpaceX, so they certainly are huge on the customer front. They about 40% of our launches are for NASA. They haven't. I mean, they did pay for demonstration flights. So they were sort of a quasi-funder, but it was specifically for their needs. So it wasn't just sort of, here's some money, do what you want. It's like, we have the specific need. We'll pay you as you demonstrate milestones in that direction. In the case of Tesla, we were fortunate enough to receive a government loan last year, which was unrelated to the bailout. Unfortunately, it was announced right around the time of the bailouts, but people sort of assumed it was somehow a bailout. But the loan that we received was actually part of a program that was initiated in 2007 in boom times, and one of the requirements of that loan program was that you had to be a viable entity in your own right and provide 20 to 30% of private capital as a matching contribution, which therefore excluded, for example, GM and Chrysler, who were bankrupt. So Ford, Nissan, and Tesla did receive essentially lines of credit and which are specifically rated, in our case, specifically related to the engineering and production costs of the Model S. So it's certainly helpful from a capital dilution standpoint. And then if we repay the loan early, then there's no capital dilution. But if we don't repay the loan early, then the U.S. government gets a bunch of stock warrants in Tesla. So I think it's a pretty sort of smart. I mean, in the grand scheme of things, of the various government deals that are done, this is, I think, one of the smarter ones. Yeah, I think, I mean, there will be many sources of electricity that are sustainable. There's, obviously, wind, geothermal, hydro, and but my personal view is that solar power will be, we will generate more electricity from solar than from any other single source. It may not be a majority, but I expect at least plurality from solar power. And that would be a combination of photovoltaics at the point of use, roofs of houses and businesses, which is also good from the standpoint of not requiring additional power lines. And then at the power plant level, I think we'll see a lot of solar thermal power generation, where you're essentially just using the sun to heat a working fluid and then generate steam and power turbine. There are a bunch of those projects that are going to come online in California and a few other places in the United States soon. And if you think of solar power, I mean, if you think of sort of beyond humanity's need for electricity, the Earth is almost entirely solar powered. The whole weather system is solar powered. Almost the entire weather system is solar powered. A little bit of it is from Earth rotation, but all precipitation is solar powered. The only reason we're not a frozen dark ice ball at 4 degrees Kelvin is because of the sun. And the whole ecosystem is solar powered. I mean, plants are essentially a solar powered chemical reaction. So really we're just talking about replacing this itty bitty thing called electricity and having that also be solar powered. Thanks. That was the intent. That was the whole idea. No, I don't think so. Like I said, the whole purpose of Tesla was to draw the rest of the car industry into electric cars. So the more electric car programs I see being announced, the happier I am. The success of Tesla as a company financially is going to be a function of the quality of products that we produce. So we have to make better cars than, say, GM and Chrysler. I don't see that as a huge challenge. So, no, I mean, the sad thing is that generally in the United States, if people can afford an expensive car, they do not buy an American car. And I think in the 60s, the U.S. made great cars, and before that made great cars, but then something happened in the 70s. I don't know what happened. It was a lot of bad things. Architecture went to hell, fashion was questionable, and our cars turned to shit. So I think, actually, as a friend of mine summarized the Tesla strategies to, in the long term, is to make cars that don't suck. So I think we'll be okay. And And there's some vindication in that Toyota, which is the largest car company in the world and the leader in hybrids, is an investor and partner with Tesla. And if it was easy, they would simply do it themselves and not bother to partner with us. Daimler was the inventor of the internal combustion engine car, the maker of Mercedes and Smart. And again, they would not ask us to be a supplier to them, nor would they be an investor in Tesla if they thought it was a simple matter to replicate what we're doing. Sure. No. This aluminum is great. The Audi A8, for example, is an aluminum car. All the airplanes that you fly are mostly aluminum, and aluminum is harder to work with in terms of bonding and joining. It's harder to weld than steel, for example. So it is technologically more difficult to work with, but it is a superior metal for anything where weight is important. That's why planes are not made of steel. In fact, the Model S, our design target is to meet a 5-star crash rating by 2012 standards, which are higher than a car that's 5-star by 2010 standards is only a 3-star by 2012 standards. So we have a very high bar that we're aiming for from a safety standpoint. And obviously, I'll be driving the car. My friends will be driving the car. Our beloved shareholders will be driving the car. So safety is extremely important. I don't think there will be a safer car on the road. Oh, sorry. So the price. It's kind of like a 5 Series BMW, so depending upon configuration, it would vary from about $50,000 to $100,000. Yeah. Sure. Mm-hmm. I generally think that that there's been a bit too much outsourcing in general, both outsourcing out of California, outsourcing out of the United States. Business sometimes tends to be a little fatty. It's sort of like there was for a very long time a very strong outsourcing fad, but I don't think people really looked at the fundamentals in a lot of cases when they outsourced, and particularly when the technology is evolving rapidly. I think it's important to have a tight iteration loop between engineering and production. So as soon as you've designed something, you can bring it to production right away, and you can get the engineers can go on the floor and see the mistakes that they've made. The production people can talk to the engineers and say, here's some good ideas, and so you can evolve the product and achieve get to a better design solution faster. I think this is an important thing that's often overlooked. At SpaceX, our rockets are lower cost than the Chinese, Indians, or anyone else, and that's before usability is taken into account. And I think it's because of that tight iteration loop. And in the case of Tesla, the Fremont plant, the NUMMI plant, they until April 1st of last year, they made the Corolla there, which is a $17,000 car. So if it was fundamentally if it was fundamentally too expensive to operate in California, how could they make a $17,000 car? So we in California, I think we do need to be cautious about adding more and more costs to living here. I do think we're close to we're on a cusp of a tipping point. If the taxes start getting, much higher than they are, if like in California, the marginal tax rate is 11%. You could go to the state of Washington and pay 0%. So it is an expensive place to live. I like living in California, so I'm here. But I know many people who've moved out because the taxes are too high, or the workman's comp and other costs are too high. California does I think tend to overregulate a little bit. So I think generally California is going to have a really tough thing to do, which is it's got to cut the cost of what it spends at the state level, and maybe even reduce the taxes a little bit to be competitive with other states, and deregulate. Those are the things that can be done to increase employment in California. Politically, these are difficult things to do. And I'm not entirely sure how California gets out of this bind. It might have to be a proposition or something, because the legislature seems unable to arrive at anything sensible. Sure, sorry. No materials limitations in space. Silicon, don't worry about silicon from a limitation standpoint. There's lots of silicon. Copper is probably okay too. There's quite a lot of copper in the world. For battery packs, one of the challenges we had was cobalt. Actually, cobalt is only available in a few places in the world. It's quite expensive, and the biggest source is the Congo, which it tends to vary in its political stability. So that's why going to the Model S, we changed the chemistry to require only about a quarter as much cobalt, and thus reduce the cost of the battery pack, and actually also increase the energy of the pack. If you're going to worry about any material shortages, maybe some rare earth elements are maybe a concern. China has a huge concentration of rare earth elements, which are used in permanent magnet motors. To avoid that issue, well, actually, there are other reasons for it as well, but Tesla has an electric motor design that doesn't use any rare earth elements. I think we're generally okay on the commodities front. I wouldn't worry too much about it, except for the non reusable commodities like oil and that kind of thing. So by the way, oil prices are going to go way up, in case anybody's wondering. I want to make sure somebody, okay, in the back there. I'm not too worried about recharging stations. The great thing about electricity is it's really ubiquitous. I mean, there are more power outlets than access to any other kind of energy by orders of magnitude. In the case of Tesla and most of the new electric cars that are coming out, the charger is built into the car, so you can plug it in almost anywhere. If you want to charge fast, you're going to need a high power outlet. But what we're seeing with the use of the Tesla Roadster is almost all charging occurs at home. Like 90% plus. Now, it is important that you have a range that is reasonable. And if you've got sort of a really low range, like say 50 miles range, then well, you can't do a lot of round trips. I mean, 25 miles is your max, and you're being pretty sporting if you do that. So as you reduce the range, you start to require a lot of charging stations. But as you increase the range, the number of charging stations you need tends to drop with the square of the range. So you've got sort of a circle that you can travel in, and so the bigger that circle is, the fewer recharging stations you need. So for something like the Tesla Roadster, you only need one charging station between LA and San Francisco. It's a 400-mile trip. You get 250 miles of range, so you just need one charge station. but if you had a 50-mile range, you'd need probably 10 charging stations. 8 to 10 charging stations. So I think you'll really only see a lot of use of charging stations, at least as far as Tesla cars are concerned, on the interstates. So when you're making really long distance trips, that kind of thing. But otherwise, not a lot of charging stations are needed. Yeah. Yes. Sure. So in the case of SpaceX, unfortunately, the supply chain in the rocket business is very shallow. Very often there is only one supplier, and it's a very expensive supplier, and they're really not designed for reusability. So you're screwed if you don't make it yourself, basically, for the most part, and so that's led to SpaceX being sort of maybe 70 to 80% of the rocket being built in-house, literally from raw material. And I guess another way to look at it is, to the degree that you inherit the legacy components, you inherit the legacy cost structure and limitations. So it is not from any sort of religious bias towards insourcing, but rather because on the fundamentals we were driven to do that. In Tesla, in the case of Tesla, the automotive supply chain is much better. It's much more competitive. There are many suppliers for any given component, and so maybe 40 to 50% of the Tesla Model S is insourced. Yeah, that's true. You mean use parts that are in our rocket in something else that they're doing? Not yet. There've been a few inquiries about using our engines in some other programs, which we've responded to, and it could happen that our engines are used in some other government programs. We do, yeah. Well, just distinguish between heavy lift and super heavy lift, because there are rockets that, like our Falcon 9 Heavy, and there's the Delta IV Heavy, and these are sort of on the order of, in the case of Delta IV Heavy, it's about maybe 25 tons to orbit. In the case of Falcon 9 Heavy, it's maybe 35 tons to orbit. But compared to the Saturn V, which was over 100 tons to orbit, it's there's a pretty big difference there. So generally we call that sort of super heavy in the 100-ton plus class. Yeah, SpaceX would really like to build a super heavy, and I think we could do it for a small fraction of what people think it would cost. Actually, I've gone on record as saying I think we could do a super heavy for development for on the order of $2.5 billion. Prior other estimates sort of are about 10 times that, and the super heavy that I'm just alluding to would have about 160 ton to orbit capability, so way more than a Saturn V. In fact, I've even gone as far as to say that I will guarantee that personally, and stake everything on SpaceX that it will happen. So, we'll see. There are strong political forces that don't want us to do that. So I'm trying to eliminate any argument that they could have for not at least allocating a small portion of the super heavy lift funding to give us a shot at making it work. They can take all the rest of the super heavy lift funding and apply it into the traditional way. We will take the sort of 10 to 20% of that number on a fixed milestone basis. So if we don't achieve the milestones, we don't get paid, and I will personally guarantee it. So, if we don't achieve the milestones, then that money can then be applied to the other programs. So it is a no-lose proposition. But logic does not always prevail. Right. Sure. Yeah. 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 I think Tesla will be okay. I would say on balance the federal government has been helpful to Tesla, yeah. So in the space arena, well, man, this is a complicated situation. But the out of necessity, NASA has out of budget necessity, NASA has gone commercial as far as cargo transport is concerned. And then last year, President Obama said, well, we should also outsource astronaut transport to commercial entities. If we can fly in Boeing airliners and Airbus airliners and feel good about that, then why can't our spacecraft be built by commercial entities too? But there was a battle royale last year against that, which won by a 3% margin in the House of Representatives. It was a hairy battle, but it is moving in that direction. It's somewhat unavoidable. I mean, it's going to be that or nothing. So I think it's going to be that. Yeah, so overall, I'm pretty optimistic about it. I'd probably worry slightly more about in the space arena about some of the big government contractors. They would definitely like to see SpaceX die. I'm sure I'm being tortured in effigy right now. You know how when you see a movie and like there's the bad corporation in the movie, that's like the big defense contractor. So those are a competition in a lot of cases. So yeah. Okay, I'll take a couple more questions and go ahead. Great. I'm a huge fan of NASA. Yep. Yeah, that's happened many times. Actually, we didn't start out insourcing. 70-80% of our hardware. Initially, we thought we'll try to do as little as possible, but then over time we just insourced more and more out of necessity, and we found many times that we would sign a deal for supply of a component, and then that supplier would find a reason to triple the price. And so basically, as soon as they thought we didn't have any way out, then they would start with the conclusion, which is triple the price, and insert reasoning. That's happened several times, and then we've insourced the part to this price. But often with a lot of grief. Yeah, I'm very pleased with how things are now, but it was very, very hairy for a couple of years there in late 2007 through, say, first half of 2009. We came close to not making it. So. All right, last question. Is this somebody who I've been ignoring for a long time? Okay, all right, go ahead. Sorry. You're welcome. Richard who? Actually, I'm a friend. I mean, Richard Brandt's a friend is a friend of mine. He's a very affable guy. He's not a technologist. So he's sort of. His strength is brand and marketing and that kind of thing. He's very good at that. I think going into the rocket game is tricky because it is very much a technology problem, so I think he's going to encounter some challenges there. Also, what Virgin Galactic is doing is a suborbital flight, which is only about 1.5% of the energy that you need to get to orbit. So it is a much simpler problem. It's basically you shoot up to about sort of 60 to 70 miles, and then you fall down. That's essentially what they're doing. It's like the world's best roller coaster ride. So it's like a really fun trip, but it's not a technology path that would ultimately take us off to other planets and that kind of thing. But I think for a lot of people, there's not a clear distinction between getting to space and getting to orbit. And space is somewhat of a loose definition. It's kind of where does the atmosphere get thin, and you can sort of define how thin is thin. It's pretty darn thin at 60 miles altitude, but you can't have a satellite up there because the satellite the orbit would decay very quickly and it would re-enter. And going up and staying up is actually about how fast you're zooming around the Earth. It takes much more energy to do that sort of zooming around the Earth bit than it is to get to altitude. In fact, the only reason you need altitude at all is to get out of atmospheric drag. If Earth had no atmosphere, you could be orbiting Earth at like an inch above the ground. So to get to orbit, you need at least to go about 25 times the speed of sound on it for Earth. And the energy required scales with the square of the velocity, so that's, say, 625 units of energy. To do a suborbital flight, such as what Virgin Galactic is talking about, you need maybe about Mach 3, which is 9 units of energy. So it's a pretty huge difference. And then if you want to re-enter, you have to burn off 625 units of energy or burn off 9 units of energy. So it's just a giant difference. So, all right, well, thank you.